Seeing the solar cooker, solar air conditioning, and solar refrigeration. Now let us see the solar cooker. Solar cookers concentrate sunlight onto a receiver such as cooking pan. The interaction between the light energy and the received material converts light to heat, and this is called absorption. And the conversion is maximized by using material that absorb, conducts, and retains the heat. Solar cookers convert light energy into concentrate heat energy, and this energy is used for the cooking food. For solar energy, that is radiating, that is falling on this one, and here there's a reflector is there. The conversion of the sunlight to heat energy occurs when the photons of the light waves interact with the molecules of the substance. So sunlight is converted into heat energy by this method. And the electromagnetic radiation emitted by the sun have energy in them. When they strike, the energy causes the molecules of the matter to vibrate. And the molecules get excited and jump to higher levels, and this activity produces heat. So this is a way in which the heat is produced when solar radiation is hitting the surface. Therefore, that is the concept of producing heat energy from the solar radiation, which is used for the cooking purpose. That is the basic concept of solar cooker. Now let us see the different types of solar cookers. Solar cooker, one is called the box type of solar cooker. That is what is shown here. Then parabolic dish type solar cooker, that is another one. And community solar cooker and advanced solar cookers. Therefore, these four types of cookers we'll be discussing. And the first one is the box type solar cooker. This is just like a box, and here there is of course a reflector is there that reflects the solar radiation and made to fall. And the inner box, that is a painted black from the inside. They say painted in black. That when solar radiation falls here, it is getting heated. Of course, the container with the food to be kept is inside the box, which is painted with a black inside, and the outer is a wooden box as such. Therefore, this is the box type of solar cooker. And other types we'll see later, that is parabolic type, community solar cooker, and advanced solar cooker. This is a parabolic type. In that one, in that case, solar radiations are made to concentrate on this pot. This is here that pot is kept that one. Therefore, in that one, there is a reflector is there, and solar radiation is reflecting towards this location, which is where the pot is kept at. So that's the parabolic stage type solar cooker. We'll see each one the next presentation, next slides. Continuing the box type solar cooker, there's a box type solar cooker in which solar radiation is falling. There's a reflector that reflects the solar radiation to the inside the box, and here the glass cover sheet is kept at the top through which the radiation is passing, and the inner metal box that is painted black, that is painted black, that is inner box which is painted black, and here the thermocouple insulator is the thermal insulation, thermocouple is provided. For these are the different parts of a box type solar cooker, and the most commonly used form of solar cooker is the box type of solar cooker. A box type solar cooker consists of the following components as such: a black box. The box is an insulated metal or wooden box, metal or metallic or wooden box which is insulated, which is painted black from the inside to absorb the more heat. To absorb the more radiation or heat, that is inside, it is painted black, and it is thermally insulated by using thermocouple arrangement. Then there's a glass cover is there. That is at the top there's a glass cover. A cover made up of two sheets of toughened glass held together in an aluminium frame is used as a cover for the box. This for the box it is used. Then plane mirror reflector. That is a plane mirror reflector is this one. The plane mirror reflector is fixed to box B with the help of hinges. The mirror reflector can be positioned at any desired angle to the box. This mirror can be positioned at any angle. And the mirror is positioned so as to allow the reflected sunlight to fall on the glass cover of the box. Therefore, that is the radiation is coming through the glass cover, and that is the plane mirror reflector. The third one. The one is the cooking container. This is the cooking container in which a set of aluminium containers blackened from the outsides are kept in the box B. That's aluminium container that is kept inside the this box. Therefore, these are the different parts of a box type of solar cooker. Next type of solar cooker is parabolic dish type solar cooker. This is a parabolic dish type solar cooker, and this is a picture. And the parabolic reflector surface concentrate the beam reflection at the focus, where cylindrical brass vessel contains food material is placed. Here is concentrated on this one. This one is the parabolic reflector concentrates the radiation towards this point where the pot is kept, and the vessel directly receives the concentrated solar radiation. The vessel that is kept here receives directly the solar radiations, and the reflector can be adjusted to track the sun. There's a tracking mechanism is there, so that as sun position changes, this can track to the any position or to track the sun. A fairly high temperature of 450 degrees centigrade can be obtained by this parabolic dish type solar cooker. The cooking time is approximately 20 to 30 minutes. So this is the second type. First one is the box type solar cooker. This is the next one, parabolic dish type solar cooker. The third type is the community solar cooker. That is, community solar cooker has large automatically tracked parabolic reflector standing outside the kitchen. Large parabolic, therefore large number of parabolic reflector is there, and these reflector reflects the sunrise into the kitchen through an opening in its north wall, and secondary reflector further concentrate the rays into the bottom of the cooking pot, which is painted black, and it can cook all type of food for a community. That's why it is called community solar cooker. Widely it can be, for a large number of persons, it can be for food purpose, it can be used. So for a community it can be used. That is why it can cook all type of food for a community. Or in another design of community solar cooker, large number of automatically tracked parabolically reflectors are installed in series and parallel combination and generate steam for cooking in the community kitchen. Therefore, no provision for the storing the thermal energy. There is no provision to store the thermal energy. It can be used to cook a large amount of food that can be used for a community. That is why this is called a community solar cooker. Now let us see the fourth one, that is advanced solar cookers. Advanced solar cookers, the schematic diagram is shown here. And here the main disadvantage of previously explained solar cookers, box type or parabolic type concentrated or community solar cooker, all this one, the main disadvantage is that there is no provision for storing thermal energy. So cooking is possible only if the sun is available. That is the disadvantage of previously explained solar cookers. Now, advanced type of solar cookers has been designed to overcome this difficulty. Now, to overcome this one, it consists of two parts. One, an outdoor, that is, there's a cylindrical reflector is there. This is a cylindrical reflector at the outdoor side, and indoor side. At the indoor side, there is a insulated hot box reservoir. This is a reservoir which is insulated reservoir. Insulated reservoir is the insulated one, and this is the insulated reservoir. That is the interior. It is there. Now oil is to transport the the heat energy. We are using oil is used to transport that one. Therefore, the oil is used as a heat transport fluid from the collector to the hot box reservoir. From the collector, that heat energy is transmitted through the oil, which is passing through this one, through the oil, and that is given to the, that is coming to the hot oil is coming to the reservoir here. Therefore, the oil in the receiver tube rises up. Therefore, the oil is rising up as it is getting heated up. As this goes through the collector, and since the radiation is converted to heat energy, that oil is getting heated, and that heated oil is moving. That is by natural convention, that the hot oil or the heated oil is moving towards this insulated box reservoir, and then oil in the receiver tube rises up due to the natural convention after absorbing heat from the reflector and stores into the reservoir. That is, stores into the reservoir. Now continuing the advanced solar cooker, the reflector has the equatorial mounting with adjustments for seasonal variation of the sun or arrangement for the automatic solar tracking mechanism. Therefore, this is a tracking automatically it can track the solar tracking mechanism is there. Therefore, these type of solar cookers are especially useful as large size community cookers for military camp and hostels, etc. They'll be using. Advantage is that even though there is a solar radiation that already stored hot oil that is stored in this one, that heat energy can be used to cook the food even in the absence of solar radiation. That is, it's a thermally storing that thermal energy stored in this one. That is the of course that consists of the insulation box reservoir, and here cooking. Here cover is there. Cooking vessel can be kept here, and this insulation is there. And here oil, the hot oil is coming to here after passing through the collector, that is parabolic collector, and that is adjustment seasonal variations. The solar tracking mechanism is there. Okay, this is the advanced solar cooker, and this type of solar cookers are especially useful for large size community cookers for military camp as well as hostel. This can be used. Now let us see the advantages and the shortcomings of the solar cooker. Solar cookers use, of course, the advantage is that no fuel is required. The solar radiation is converted into thermal energy. No separate fuel is required. This saves the cost as well as the environment by not contributing to the pollution. So that is the first advantage of solar cooker. Second, reduce the carbon footprint by cooking without the carbon dioxide based fuels. So these are the two advantages of using a solar cooker. Of course, shortcomings are solar cookers are less useful in cloudy weathers. This type of not advanced type. Other three types are not. Even cloudy days it cannot be used as such. Therefore, some solar cookers take longer to cook food than a conventional stove or an oven. Some solar cookers are affected by strong winds which can slow down the cooking process. It might get difficult to cook some thick foods such as large roast and leaves of bread. That is, the cooking that certain types of food cooking will be difficult. Therefore, this type of solar cookers. Therefore, of course, advantage is that there are certain shortcomings also there for the solar cookers. Next, we are going to explain what is the solar refrigeration and solar air conditioning. How the solar energy or radiation can be used for the refrigeration purpose as well as air conditioning purpose. The difference is that refrigeration purpose means the temperature you have to reduce less than, even 0 degree it has to reduce that one. But air conditioning means that much less temperature is not required. Therefore, the solar energy can be used in refrigeration and air conditioning. Solar energy can be used for cooling purpose based on the absorption, that is absorption cycle cooling. Solar cooling systems collects the solar power and use it in a thermally driven cooling process, which is in turn used to decrease and control the temperature for the purpose like generating chilled water and conditioning of air building, or this can be used for the solar radiation. That is how the solar radiation can be used to make refrigeration, for the purpose of refrigeration as well as air conditioning. Now continuing the solar refrigeration and air conditioning, that two working fluids are used in absorption cycle cooling. That is called refrigerant and absorbent. There are two working fluid, refrigerant and absorbent. The absorbent means that the absorbent refrigerant combination is so chosen that absorbent has high affinity for the refrigerant, and the same temperature vapor pressure of the refrigerant is higher than that of the absorbent. Now let us see, the absorbent cooling is based on the principle that the refrigerant can be bound by a liquid or a solid solvent known as absorbent. And this absorbent is to release heat during the absorption, and it absorbs heat during the evaporation, producing a cooling effect. That is the purpose of absorbent. The absorbent is to release the heat during absorption, and it absorbs heat during the evaporation, producing a cooling effect. Continuing the solar refrigeration and air conditioning, common and commonly commercially tried refrigerant absorbent combinations are: 1. Lithium bromide water, in which lithium bromide is used as an absorbent and water is used as a refrigerant. Therefore, absorbent refrigerant unit, here lithium bromide is using as an absorbent and water is used as a refrigerant. This is a commonly and commercially tried refrigerant absorbent combination. Second one is that aqua ammonia. In that one, water as the absorbent and ammonia as the refrigerant. That is the second type of refrigeration system. That is aqua ammonia system, cooling system as such. Now say this is the schematic diagram of a lithium bromide water absorption cooling system. Lithium bromide water absorption cooling system. This is shown this one. And the main components of this one, the main absorption cycle consists of 4 main components. What are the main components is, one is the generator. This is the generator section. And second one is called the condenser. This is the condenser. The third one is called the evaporator. This is called the evaporator. And the fourth one is called the absorber. This is the absorber. There are 4 unit or 4 components as such: generator, condenser, evaporator, and absorber. Instead of using a compressor, the system uses an absorber to rise and carry the weak coolant through the pump when the heat is supplied to the generator. Now in this one here, this is the collector, solar radiation collector unit, and of course here see this one, here is the generator, water is pumping through this one, and here this will be generating, and that is passed through the compressor, and then compressor output, we'll see that and how does it goes to the evaporator, and here the after evaporation we are getting the cooling sensation, or that happening here only, and then evaporator output is going to the absorber. Again absorber is connected, or that is connected, or the output of the absorber is given to the generator. There's a heat exchanging system is also there. Now let us see the working of this lithium bromide water absorption cooling system in detail. Now continuing the lithium bromide water absorption cooling system, the flat plate collector, as we have seen here, the flat plate solar collector that is used to supply that outer radiation is converted into heat to the generator. For this generator, that temperature that is the working fluid is moving here, and that it is transferred to the transmitting fluid, and that is given to the generator. Then water vapors are rise to at a temperature of less than 100 degrees centigrade at low pressure. These water vapors are condensed at condenser by cooling water supplied by the, let's say, water cooling tower is there. By supplying through this water here, this vapors from the generator. The vapors are from the generators are condensed in this setup by the cooling towers, passing the water through cooling towers, that is condensed here. After condensing this one, these water vapors are condensed in the condenser by cooling the water supplied by the cooling towers. And the condensed water is evaporated. That is, this condensed water is coming to, that is evaporated by this unit. This condensed water is evaporated by passing it through the expansion wall. Through the expansion wall, that is evaporated, maintaining lower pressure at the evaporator. That is by passing through the expansion wall as such. Cooling effect is produced hence here, and heat is absorbed from the space to be cooled through the heat transport fluid. So heat transport fluid, the cooling effect is produced in this near to the evaporator. Continuing the lithium bromide water absorption cooling system, the water vapors from the evaporator, after producing the cooling around this evaporator, after that one, the water vapor from this one, water vapor from the evaporator go to the absorber. In this case, the absorber is the lithium bromide solution is the absorbent. Lithium bromide solution is the absorbent. That water vapor coming, that one goes from the evaporator, go to the absorber, and in absorber, the liberated heat due to the absorption process is removed by cooling the water from the cooling towers. That is, again, from the cooling towers, the cooling water is coming to here. That is cooled as such. That is removed by cooling the water. That absorption process is removed by cooling water from the cooling towers. Then again, it is going to through a heat exchanger that is going to the generator, which produces the vapor. Therefore, this is the components of lithium bromide water absorption cooling system. And the advantages of this one is that the system is comparatively simpler and works at a very high coefficient of performance. Less pumping power is required due to the low pressure operation. Less pumping power is required. Refrigerant water has a high latent heat of vaporization. Water lithium bromide solution is non-toxic and non-inflammable. These are the advantages of this lithium bromide water absorption cooling system. And disadvantage is that it can be used for air conditioning only up or not. It cannot be used for not less than 4 degrees centigrade. Only above 4 degrees centigrade can make it. Therefore, that is why the lithium bromide water solution is, of course, cannot be used for the, in this same, working of the lithium bromide, that cannot be used for the refrigeration purpose. It can be used for the air conditioning purpose only, because it cannot have a temperature less than 4 degrees centigrade. For lithium, the another disadvantage is that lithium bromide water solution is corrosive and system works under high vacuum condition. Therefore, this is a lithium bromide water absorption cooling system in which the solar radiation, that thermal radiation is used for making cooling the space. That is, it is making for the air conditioning purpose that is used. Now let us see the another type of cooling absorption cooling system, that is aqua ammonia absorption cooling system. Aqua ammonia absorption. The aqua ammonia absorption system is similar to lithium bromide water absorption system. System is working in the same fashion, but same building blocks are there. Operating temperatures and pressures are different. Ammonia is a refrigerant. In this case, ammonia is a refrigerant while water is used as the absorbent. And the absorber absorbs the low pressure ammonia vapor coming from the evaporator. From the evaporator, low pressure ammonia vapor, ammonia is coming here. That low pressure ammonia is absorbed by this absorber. And lithium bromide was in the previous case, but here ammonia is coming to the absorber, and low pressure ammonia vapor coming from the evaporator is absorbed by the absorber, and it can produce a cooling up to -5 degrees centigrade. Advantage of this one compared to the previous one, lithium bromide water absorption cooling system, is that this can be make the cooling here. It is around this one evaporator, that space is being cooled, that you can bring less than of course up to -5 degrees centigrade, less than 0 degrees centigrade can be used for. That is why it can be used for the refrigeration purpose. This can be used. Therefore, a rectifier and an analyzer is added after generator to check and stop the water vapor from reaching the evaporator, and the required temperature is in the generator is around 120 degree centigrade. The advantage is that it can provide both air conditioning as well as refrigeration, and the refrigerant has low molecular weight and therefore high heat of vaporization. That is the advantages of aqua ammonia absorption cooling system compared to lithium bromide water absorption cooling system. The disadvantage is that the absorbent here, water is volatile and rectifier unit is required. Therefore here, that is the disadvantages of this aqua ammonia absorption cooling system. Absorbent is volatile, and a rectifier unit is required from the generator. A rectifier unit is required, is added to check and stop the water vapor reaching the evaporator. Therefore, these are the disadvantages of aqua ammonia absorption cooling system. And therefore, in this presentation, I explained solar cookers. There are different types of solar cookers used, as well as how the solar radiation energy can be used for the refrigeration purpose, as well as for the air condition purpose that we have explained.